Hello, welcome to this MagiCAD for Revit piping module demonstration video. It's a quick overview of the features that we offer in this module. The first tools I'm going to show are the modeling tools that are part of the piping module, so we'll get on and do that. Firstly, I want to show the crossing tool. So if we go to multi-crossing, you'll see we've got a situation where we've got a bank of 4 pipes clashing with 2 other pipes. I want to bring the 4 pipes underneath the other ones, so if I just click on the pipes that I want to cross, or set up and set down, press finish, and this time we'll go underneath, let's say the pipe it's clashing with, by a tolerance of that and 45 degrees, press OK. It will now route the pipework as a bank at that tolerance of 75mm below the other one, so you can see that's done it there. So that really saves you time when you're trying to do it in Revit and you have to trim the pipes back individually and draw a section, and then manually draw the angled pipes around and work out what the heights and offsets are. So that's a real time saver there. The other type of crossing tool we also have is horizontal crossing, which enables the user to again mitigate a clash using this horizontal crossing, but this time in like an XY plane. So this yellow pipe here is clashing with the vertical pipe dropping through it. So I'll select these points to set, I'll select a reference point to offset against, and you can see there we've got a tolerance there, an angle, and then you can flip the sides as well if you want to do that. So you just mirror that, press, and then when you're happy with it, you can change obviously the offsets and tolerances, press OK, and you can see it's now done that offset in the horizontal plane. Another situation which is handy is if you draw a section here, you'll see that we've got a vertical pipe dropping through this yellow horizontal pipe. Again, we can use this offset tool here around the yellow pipe to create a situation as we see fit for this. So you can see there we now have that offset in that manner, then press OK, and you can see there that it's now offset that pipe against the other one in that manner. So it's all quite nice tools to help you deal with clashes and coordination as you go. The next tool I want to look at is the standard connection tool. So you can see here we've got a bend that wants to connect into a pipe here. There are different offsets you can see, so quite a bit awkward really. So if we press the standard connection, we can click on the bend itself, click on the pipe I want to connect into. Actually what it does, you can see it actually creates a T-piece out of the bend and then puts an angled connection on as you see fit there. So depends how you want to set that up. So press OK, and you can see that it's actually now done the 90-degree bend there and then the T-piece there. So that's a standard connection, that's how that works. The standard connection can also work without doing that. You can just have a loose pipe, you could just use that same tool just to press and connect it in exactly in this manner here. If you want to just connect those 2 pieces together, you can use that tool as well. Another tool we have is angle to horizontal. This is to define a angle and an offset from another pipe. So for example, if I press this and I'm going to just drop off this pipe here, let's say at 45 degrees, I can choose this pipe to drop underneath and take a reference off that as well. Press OK, choose the side I want to come off at, and what it does, you can see there, it drops the pipe off the run and then puts the branch, and you can see we set an offset of 150 below there, which is now taken into account as it comes underneath the other pipe. So that's angle to horizontal on there. And finally, angle to horizontal can also be used for coming off the end of pipes like this. Again, you can drop at any angle you want and then choose you can choose the bottom of the pipe, for instance, so that could be like 2300. Press OK, and it will drop that pipe off the end like so and come around the corner, and you can see what it's done. It's dropped the pipe down at the angle being specified to the underside. And the powerful thing about that is you're not choosing Revit's center line, which is the offset. You're choosing the top, middle, which is the offset, or bottom of the objects, or referencing other objects to define the heights, which is very, very useful in that situation. Some of the things I want to show you as well in terms of connections, sloped pipes. For example, here you can see it's dropping at 1 in 80. Notoriously difficult to connect in Revit is when you've got gradient pipes. We have this drainage connection tool where you click on it. If you now click on the pipes you want to connect into, like this, you can see actually if you've got a 45 degree fitting Y piece, it will use that to connect into, and you can see there you can now connect this in. So what I'm doing, I'm say replicating how you would connect in like a spine of drainage that drops from above to a certain level, and you can see in 3D how that looks. You can see it's then puts the angles in there in accordance with that 45 degrees, and obviously rotates that fitting around to connect that up. So that's you can see there it's all 1 in 80 drainage all the way through. So that's another sort of decent pipe connection tool that we can use to create these sort of awkward connections now and again. Okay, so also what I want to look at is the pipe modeling tool. So a dialog box. If I click on the pipe here, you'll see that we can choose a piping system from the Revit model on the left hand side. So you can choose like VT flow. You can choose any pipe type that's loaded into the project, so it could be anything. It could be copper table X if you want. Choose the size, like 42 mil. But what's quite nice here is that we can now put our heights in of the pipework from this dialog box to the bottom, to the center, to the top. So if you model and then draw it to the bottom at 2500, you can see the other, doesn't matter what the diameter of the pipe is, it will change in relation to the key height or offset to the bottom, middle or top of that pipe. But also it's a nice tool. If you have this justify to selected object, what I can do is press top of and then click on this insulated pipe, for instance here, and then this will justify to the top of it. So if I now press OK on that and then draw the pipe next to it like this, if I go into that section view, you'll see that it actually justifies the top of the pipe on the left, which I just drew, to the top of the pipe on the right, which I just had in there previously. So even with the insulation taken into account as well, which is very nice. So that's what that is for. It's to justify it to the top, bottom, or even the center if you need to. So you can do matched tops and bottoms of heights of bracketry and things like that. Also in this pipe dialog box, we've got an opportunity to uncheck that box and then go on top of, and this time we can click, say you want to go over the top of this pipe with the insulation with a gap of say 50 millimeters, then press OK. And now if I draw a pipe over the top like that, if we go into that section view, you'll now see that it's now drawn a pipe over the top of the other one that's insulated with a gap of 50 millimeters there. So again, a very powerful tool to help you coordinate. So there's just a few more options I want to show in terms of the piping connection tool. One of these is like radiators. So if I just go into this area down here, I'm just going to show you a couple of unique piping tool connections that we have. So you've got pipe connection here. We can choose the whole bank of radiators, choose where I want to connect that in. On the flow and return pipe, we can choose an offset to come off in the mains, then just press OK, and then it will connect up the radiators automatically to the mains in the corridor, as you can see. So you can see it's put that, if I click in this view, you can see it's put that connection in. So it's got, there's a connection to the radiators there, and then if you look, it comes from the corridor there, so it comes off at an angle of 45 degrees. So that's that one. We have a very similar tool for fan core units, which I won't show. It works exactly the same way. And finally, I just want to show the domestics and drainage connections again. So for example, we have a basin here. I want to connect up to the boosted hot and cold water there. So if I now go to pipe connection, I can then click on that particular outlet, click on my hot and cold. Again, I could choose a drop and choose my routing preferences, press OK, and then now it will route that pipe work down, dropping in the corner and up towards that basin. So that's just one example of that. And then finally, just using that drainage connection tool again, if I want to connect up some say toilets to this sloping pipe work, similar kind of idea. We can choose the gradient, choose the connection type in there, and then choose whether it's 245s or an 88 or 90 degree elbow. Press OK, and then just repeat, and then click into there. And what it'll do, will obviously put the preset gradient of pipe work onto that connection at the same time onto the other gradient. So you can see there, if I click on that, you can see it's 1 in 80, and if I click on this pipe I've connected into, that's also 1 in 80, so it's connected 1 in 80 into 1 in 80. And then finally you can use that same tool to connect that into the stack, and press OK, and you can see there it's now connected that into the stack there. So very quick tour of the modelling tools. There is a lot more to it than that, but that's a very quick flavour overview of how they work and the benefits that you can gain from using these tools in Revit. Within MagiCAD for Revit calculations, in the piping module we cover diversified domestics systems. We cover the circulation water for the domestic hot water. We cover the heating and cooling calculations for piping, and also drainage diversification flows. On the screen now you'll see a very basic hot and cold water circuit running around here, and on that you'll see these things called connection nodes, and on the end of these what looks like empty pipes are these little connectors. And the idea of this is that at this stage, maybe it's stage 2 and stage 3 according to Revit stages, you may only have the requirement to do main distribution and size that. But the problem with Revit without MagiCAD is that you have to connect things up to inherit the technical data. So what this tool does is enable you to put these connection nodes on and represent downstream systems from this point. So you can see here we've got hot and cold with loading units, and then again here and here. So what I'm going to do, I'm just going to put a loading unit on the end of this hot water pipe here just to complete that system. So I'm just going to put some loading units and a pressure drop. So press OK, and of course you can just tag that as you see fit there, no problem at all, like so. Then all we need to do now is size this pipework in accordance with the loading units. So press calculation, domestic water sizing. You can choose velocity and pressure drop, or both, or either or, depends. You can configure that yourself. Press OK. I'm just going to calculate the hot first, so you can see there loading units and diversified flow. Press OK, and it will resize the pipework for me and start populating these. I'll come back to that in a second. And then I'm just going to do the same thing, domestic water sizing for the cold water. And you can see there, this report here, you get a little, just to go over this slightly, you get a little schematic on the left hand side of the system. You can see if you want to jump to anything in there, you must highlight and drawing it or jump to it in the model, and you get your calculated diversification and total loading units on there. So press OK, and then it will resize the pipework in accordance with that. So you can see now we've got a 35 diameter pipe, previously the 28. We've got flow rate in there as well, and it's all based on the diversification of the flow. And the actual standards I'm using in this case, if we go into the settings here, you'll see that we've got for pressure drops we've got SIBSI calcs, and then in here we've got a number of market areas covered for domestics, which is obviously UK and well, 2 standards used in the UK there, and also got the drainage systems, which is also used here in the UK. So with that selected, it will use that as a basis for the calculation and the conversion of the diversification. So that's a very quick overview of how you can do a stage sort of 2 and 3 design very, very easily with connection nodes. That also applies to heating and cooling. You can put nodes on there as well and represent heat loads or cooling loads at the end. So if I now just go to more of a detailed layout that you typically get maybe at stage 4, you can see that we've actually got these connections being made where we had connection nodes before. We've now got connections to devices, to like actual outlets like taps or whatever you've got. But we're going to look at the heating system very quickly. So you can see we've now got, instead of connection nodes, we've got actual mechanical equipment connected. In this case, we've got, looking properties, you'll see it's a chill beam. You can see it's got a cooling load going into it, etc. So with all that connected up, what MagiCAD does, it takes a delta T of the flow and return temperatures from Revit, and then looks at the output required at each of these inputted fan coil units in this case, or radiators or whatever it is, and then using that as a basis it can calculate the flow rate and hence the pipe sizing. So if we go into here, you do heating and cooling sizing, and very quickly we can just again choose a method we want to do that, press OK, choose the heating and cooling sizing, and you get a sizing report up there, press OK, and then it will size the pipework accordingly, flow and return in one hit. And then once we've done that, we can then go into the balancing calculation now. So if we go into piping calculation, go heating and cooling balancing, what you'll now see is we can go and just choose the heat system again, but this time we'll get this report, and you can see the schematic. You can see down the left hand side all the components listed out, and it's got supply and return in this. If you want to look at the index run just as a whole, you can right click, show that route only. You can see there's the supply, and there's the return back to 0 pressure, as you'd expect, all the way up from the total system pressure, which looks like it's 9.9 kPa in total. So that's how that works. But at this stage as well, if you want a copy of this report, you can either print to PDF or copy to clipboard. So I'm going to print to PDF, and you'll get like an official looking PDF report printed out here. So I'll just press save, and you'll see that we have a nice heating report. You can see there all the detail comes from the Revit project, and it's got the calculation data, what sort of system it is, delta T's, total flow rates, pressure drops, everything like that. And then down below you can see all the individual components that are a part of that system as we defined in the previous window there. So if you're happy with all that, just press OK to update the model, and you can see there it will populate all the pressure data in the system. So it's quite easy to use. And also in that calculation, I'm not going to show this, but I'll just explain, you can actually as well balance to a pump pressure, or you can put your own feed pressure in, all things like that. So you've got a lot of scope for how you want to configure your pressure drop calculations and sizing. So that was a bit about the heating and cooling. And then lastly, for the drainage, I just want to touch on that. It's got a very basic drainage system here, and what we can do is go into calculation and drainage flow in accordance with that standard we selected in there before, and then you can choose your usage factor, what you want to put in there, press OK, click on the drainage system, and you can see it now does the diversified drainage flow for this system. So you can see there that we've got 5.4 discharge units accordance with that standard. In this case it was EN 12056, and then diversified flow is that. So you want to calculate your stack flows and things like that, and communicate those with your structural engineers for your below ground drainage, then that's what you can do. It's very, very handy. And once you've done that, of course, if you want to, you can then produce something like this, where it's more of a sort of isometric kind of layout, where you have the drainage system in here, you can see, and then you can put the falls, or you can put the flow rates. I want to do like almost like an isometric plan there, you see. So something else, just another idea of what you can do. So that has been a very quick overview of the piping calculations in this module. There's obviously a lot more to it than that, but I hope it gives you a good flavour for what can be achieved with MagiCAD Revit calculations. Now we're going to look at how we install products into Revit using the MagiCAD library or MagiCAD functions in Revit. First of all, we're going to look at, for example, just installing something like a a valve here, so just press install product. You can see it's got the piping discipline there, all the different categories that relate to that. So let's go to zone valve, and you can see there's some manufacturer's zone valve. If you right click, look at the properties, you can see there's the zone valve there. You can choose a different symbol from a symbol library. You can customize that yourself, you don't have to use our symbols, but they are preset in there in accordance with British standards. And then there's also some properties you can look at for the different diameters of this valve will have different pressure drop and adjustment values. So anyway, if you press OK, we can then install this valve into the project. And using this smart toolbar, you can either choose the size that you want. You can choose continually that size, or you can choose auto size here. Press auto size, it will find the most appropriate size for this pipe you're trying to install it on, and then select it from the cloud and then install it. And you can see there it's done that at 15 mil. So that's installing a valve, quite straightforward, but a very useful tool nonetheless. Let's install something like a radiator. So I'm going to go into same menu again, but radiator this time. And in here, I mentioned this before during the calculation, is where you can choose the systems that you put these different objects on, or these products on. So you can see there's the heating flow returns 80/60, so delta T is 20. You can choose your manual sizing should you wish to choose different sizes of radiator like that, or you can choose select size and choose it from a sort of list of criteria if you've got heights and lengths and widths that you want to choose from instead. So you can choose whichever one you want, so choose that one, press OK, and there's my calculated output, and then press OK, and that will create that radiator family for me, which enables me to insert this into the project. But at this point I can also which is quite a nice tool as well, select some valves. So I'm going to choose some 15 mil TRVs and lock shield valves. Again, press OK, and MagiCAD can actually attach those valves to the radiators upon insertion. And the final thing I want to show you in this floating toolbar is that you can actually change the orientation of the sort of inlet and outlets positions, as you can see there, in accordance with the product. So you can choose, top, bottom, opposite end, bottom, same end, whatever you want to do there. It's all doable. And then you can choose an array, and you can choose to, so as the name suggests, create an array of multiple items. This time I'm going to draw a line, and it's going to be 8 instances to match the 8 offices. And I'm just going to draw a line down this wall, let's say to here, and then distribute the radiators evenly. So you can see there I've now put 8 radiators down that wall, and if I want to put distances I can, but this is just one way of doing it, dividing it equally. If I'm happy with that, I can press OK. I can also press an offset, so I want to put a little gap between the back of the wall. If I want to put it at say 40 millimeters and press update, you can see they all move slightly. And if I'm happy with it, press OK, apply, and then now it's going to create the valves on the radiators for me. So what you can see has happened, it's inserted all those radiators with the TRVs there. There's a TRV on the end of the radiator, and they're all aligned perfectly in those offices, and you can just use the connection tools to pipe all those up. So that's a little bit about how to install like valve, and then obviously a radiator as well. The same logic goes for any item really. So how do I bring something in from the cloud, let's say, rather than something that's already in the data set? So if I go to install product, I'll choose a whole new category. Let's go for climate beam, let's say, and in here you'll see we've got a list of climate beams, got 2 of them in this data set, but I want to choose something different, so I can go into there, into properties, and then go to the MagiCloud, which will take us onto the internet, which is now going to browse through our online library of all different products. I'm not going to spend too long in here, but let's give you a bit of an overview. So you can choose different manufacturers, you can type it in the search engine if you want. So if I want to type in like flat woods, I can just type in woods in there, and it will filter it down to that manufacturer, choose different pipe and connection size and different attributes like that, and just press insert, and you can see now that flatwoods beam, you can see flatwoods is now inserted into the project, and there's the properties of that particular climate beam, you can see the 3D geometry there with the connection spigot size for the ducts and things like that. So, and you can see the heating and cooling graphs in accordance with that as well. So that's how that works, and press OK, and now that's part of this. That's now part of this data set, and you can see here you can have different systems. Again, you can put CT flow, CT return, chill water, flow and return, like that. Different outputs in there depending on the particular conditions that you've got, and then the heating and cooling graphs can update accordingly. If you're happy with that product, press OK. What it'll do, it'll convert the product from the cloud into a Revit family and then insert it into the project with those technical conditions preset into it, so you can start putting those items into the project with the pipe connected up, and then you can do the calculations as we showed in the previous calculation part of this video. So I'll just go back to free. You can add all the different categories of heating in here, so you can choose a system and name and press OK, and that way you've got this defined, and just drop that climate beam into this office like that. And now if we wanted to, we can then start calculating the flow rates based on the outputs for those particular heating and chilled systems for these climate beams. So that's how to do that. And it's worth mentioning before we finish, you've looked at the MagiCAD library. I've showed that. Can we use third-party families, like ones that didn't come from our cloud or from our library at all? Yes, you can. So there's a fan call unit that I've downloaded from the internet. It's nothing to do with MagiCAD at all. It's just a Revit family come off from some third-party website. You can see there that I've got some heating pipes going into it. If I just run that calculation again for the heating system, let's say, I will show you how that works. If I just click on the heating pipe there, press OK, you will see that if I scroll down, or even like I said before, you can even click on the item itself, and you can see there that it's this fan call unit from the internet has an output of that, and everything is all calculated back up through the system there, back to the start. So it's not a problem at all. These are third-party families. It can work with inserting your own heating and cooling loads, and also on top of that you can also insert your own pressure drops for those particular components. So I hope that's been useful. You've seen all the installing of products and how that library works now, and how that interacts with the calculator systems. That's the end of this demonstration video. Thank you for your time. You can see on the screen now ways of getting in touch with us in the UK by email or phone. So please get in touch and we can provide any more information you require. Thank you very much.